we're just going to be solving them algebraically, and then we'll also show the solution on a graph. Really, it's on a number line. When we're solving inequalities, the only thing that we have to look out for is when we multiply or divide by a negative, because that's going to cause the sign of the inequality to flip. Really quickly, just to show you why the sign switches when you multiply or divide by a negative in the process of isolating your variable. Let's just say I had something like 4 is less than 10. Just really quick, again, this is an inequality right here. The mouth is towards the 10, so it's saying 10 is greater than, and the pointy part towards the 4, so it's saying, this is saying 4 is less than 10. So let me just go ahead and divide both sides of this by 2. Because whatever you do to one side, you do the other. So this will be 2 is less than 10. So when I did that, the statement is still true. 2 is less than 10, so this is valid. But let's see what happens when I divide by a negative 2. So 4 is less than 10. Now this time let's divide by a negative 2 and see what happens. So on this side we get negative 2. And on this side we get negative 5. So now when we look at the statement, it's actually false because it's saying negative 2 is less than negative 5. But we know that's false. We could look at a number line, or however we want to look at it, but this is false. So that wasn't really a proof or anything. It was just a quick explanation of why we have to switch the sign when you divide or multiply by a negative. Okay, so let's get into the first example here. So this is just a regular linear equation. To make it a linear inequality, I'll just have to put an inequality there, like so. So now this is a linear equality, which is what we're working on today. So when we solve this, you want to just go ahead and just treat that inequality sign as an equal sign, if that helps, like in the process in your mind while you're doing it. Because I've just seen that symbol tends to throw a lot of people off, or they get intimidated by it. But really just treat it like an equal sign and just isolate regularly. So if I were to isolate this x, I would subtract 2 on both sides. Then I would get that 5x is greater than 10. Then I would divide both sides by 5 and get that x is greater than 2. So this is what I've come down to. What this statement is saying is that the value that you pick for x to set this original statement true, it has to be greater than 2, like 2.1, 5, 100, anything bigger than 2 to make this statement true. And the 2 is not included. So yeah. Alrighty, so here's a second example, linear inequalities. Let's go ahead and solve this like regular, and then let's go ahead and show the solution on a number line as well. Alrighty, so to isolate this, I'm just going to treat that like an equal sign in my head and just it's nothing new, right? So subtract 2 on both sides. Then you get that negative 5x is greater than 10. This time notice we're dividing by a negative. And we said in the beginning, if you multiply or divide by a negative in the process of isolation, the sign switches. Then you get x, or switch that sign, and get negative 2. Okay? So this is telling me to satisfy your original equation, the x value that you choose has to be less than negative 2, and negative 2 is not included. Okay, so alright, so here's the solution we got from that previous example that we did. We got that x has to be less than negative 2. So just really quickly, here's a number line, or I've attempted to draw one. 0 is always in the middle. If you move to the right, it's positive. If you move to the left, it's negative. So negative 2, I'm just going to scale this by 1s. So negative 2 would be right here. And in the process of showing our solution on a graph, we have to shade a certain way. So this is telling me x is less than negative 2. And if I want my values to get less and less, I know I have to go to the left. So we're going to start at negative 2 and shade to the left. But when we're showing our solution on a number line, when it's in this format, when it's just an inequality sign, when it's not equal to, that's saying that we're not including our negative 2. So we either indicate that with a parenthesis, I had a hard time saying that, or just use like an open circle to indicate that. So I know I'm going to start here at -2 and I'm going to go this way. But at -2 I could use a parenthesis to indicate that, or we use like this open circle. So that looks ugly, but we'll do some more examples and then we'll get the feel of this. Yeah. So just leading off that first example we did, we isolated the variable and then we showed the solution on a number line. Another common thing that's related to inequalities is to give your answer in set notation and interval notation. So set notation, we use like these brace things. So to write this in set notation, I'm going to open up a brace, put the variable that we're talking about, which is x, and then we put like this little straight bar here. What this is saying is that x is valid or true for these statements that we're providing. And what we're going to provide is that x is less than -2, and then we're going to close up that brace. So this is just saying x such that this is true. It's just the notation we use. So set notation's got braces. Now when we move on to interval notation, it really comes down to using parentheses and brackets and the infinity symbol, because we're saying x is less than -2, so if we keep going to the left an infinite amount, we're going to get to -infinity, and if we go to the right an infinite amount, we'll get to +infinity. So we just like to denote that when we use interval notation. So this is saying x is less than -2, so the smallest value I could have coming in is -infinity, and we never include infinity, so we always just put parentheses on them. So we come in from -infinity and we stop at -2, and -2 is not included, so we use parentheses for that. So alrighty, just moving along here. The only thing that's different about this is now what this is saying is 3 minus 2x is greater than or equal to with this little bar here. So the previous examples we did was like that. When you have a little bar underneath, it's just saying it's greater than or equal to, or less than or equal to. We'll find out when we isolate for x, right? So isolating for x, we subtract 3 first. So we get that -2x is greater than or equal to -8. And we divide by -2. So we get that x is dividing by negative in the process causes the sign to flip. So we get that x is less than or equal to 4. So now when we graph this on the real number line, we're actually going to include 4 now. So plugging 4 back into this statement would also set this true, and anything less than 4 would also set it true. So we're going to go ahead and put it in set notation, interval notation, and show it on a number line when we come back. Alright, so let's go ahead and put it into set notation. Set notation has those braces. So here comes the brace. The variable we're using is x. So x such that whatever holds, which is this. I mean, in my opinion, set notation is really not that bad. You just pretty much put what we already got into here. You just add the braces and the x in the line. Alrighty, so for interval notation, that's when we use infinities if we can, and we use parens or brackets. So x is less than, so we're going to the left, which is the farthest to the left is -infinity, and we never include infinity, so there we go. And then we come in to 4, and then we stop, but this time we're including 4. So this time we use a bracket instead of a paren. And on the previous example, we used a paren or an open circle to indicate it on the real number line. Now that it's a bracket, we're going to indicate that with a closed, filled-in circle and a bracket. So, let's see, 1, 2, 3, 4. 4 would be right here. One way we could do it is if I were to do like a circle on 4, but I would have to fill it in because it's included now. And we're going to the left, so I would just shade anything to the left of that. Or we could use a bracket on 4. So one thing I wanted to point out is that as far as knowing which way to shade, in the process of isolation, if you get your variable to be on the left side, like I do right now, you could treat your inequality sign kind of like an arrow. You see how if I were to rewrite the inequality, it's like an arrow and it's telling me which way to go. But this only works if you have your variable on the left side. So this is pretty much telling me to shade to the left. So I just wanted to point that out.